And I'd also like to thank Transporter Educators for giving me this opportunity to speak with all of you. I know it's exam week for many of you there, so from my experience in ICT, it's very thick, and I appreciate that you are still here to listen to my talk. Um, Next slide. There. Okay, so I started my engineering journey back in 1998 when I joined ICT. It was called UDCT at that time. I was really clueless about engineering, knew nothing about it. And then I started learning more about chemical engineering, liked it, and I had opportunity to listen to many of the seminars like today. And some of them were informative, I could understand, and some of them went over my head. Um, Hopefully this is not the one of. After that, I did my PhD in chemical engineering, as Dr. Vishwanath said, in process control. I'll be talking a little bit about that. And now I'm a process control and optimization engineer at ExxonMobil. Here, brief outline talk. We'll discuss a little bit about background of process control, and we'll talk about process control applications. Just a brief overview. I'm not going to go in the theory of how it's done, but just to give you an idea of what applications are out there in the industry. And we'll talk about basic regulatory control, single variable, multi-variable control, and finally real-time optimization, which is the field I'm currently working in. This is by no means intended to be a very comprehensive list of applications. It's just what I have seen while working in the industry. We'll move on. Next one. So are you ready for some advanced process control? It appears that the job of a process control engineer will be very cool. You're working with applications all the time. You can watch football on the side, as the cartoon shows. But it's also really a very critical job in the plant. You have to concentrate because any mistake you do can be dangerous and critical to the safe operation of the. So that we'll just go in a little bit of background of how a process control application started in 1950s, and at that time it was all manual control, meaning somebody would look at the sensors and see how the reading was. They would manually change the valve as shown in this cartoon here. You see the man in the cartoon is smiling, but that's not usually the case. It's very a hot and very difficult place to work, and operators don't appreciate having to go out and manually move the valves. And imagine there are hundreds, if not thousands, of process control loops out there, and if every one loop there's an operator that needs to be looking at, it's very safe. So the manual control basically led to the development of more automated control schemes. And with time, we can see in this what I'm showing you is the number of fatal injuries um, and how they have trended over the last couple of decades. This graph was put forth by Osha, which stands for Occupational Safety and Health Administration, and it is put in regulations and controls to reduce the workplace injuries. Over time, the number of fatal injuries have gone down considerably. Now, for each fatal injury, there are many more minor injuries that happen inside a plant. So you can see that due to the regulations been put forth and the controls that have been put in place, the number of injuries have gone down over the year. And that's the value of process control to a operational unit. So how does the transition from manual control to automatic control happen over the years? Well, there were many developments that happened, and one of the primary ones was in the field of uh, instrumentation, where the instruments were able to make readings accurately as well as send them to the distributed control network for um, for the auto controls, as well as the other important development was the um control element, which is usually a valve. In this case, the change was from a manually controlled to a pneumatic or automatic or a motor-driven control valve. Here in the picture below, I'm showing a pneumatic control valve. What it does, it uses air pressure to move a diaphragm that controls the opening of the valve.
Good morning to all of you at ICT. Uh, Let me take the opportunity to thank the organizers of Lecture B to bring me to you live from US. And here I must thank Gaurang who texted me long distance and made sure that this link goes live. What am I? Just give me an indication whether I'm audible enough and there is no disturbance, so that I will proceed.
So slightly louder.
Okay, is that better? Hello?
Yes.
Okay. So what I am going to talk about today is optimal design and control of bioprocesses. Before I go to the main topic, let me give you a brief overview of what is happening in the field of industrial biotechnology in India. So there are about 400 different kinds of firms or companies in this field with an annual turnover of about 8,000 crores. We can broadly divide these companies into healthcare, food and agriculture, and industrial biotechnology. And as you can see, the dominant impact is in the field of healthcare and natural resources. Now, if you look at the activity, what are different type of things happening in the field of biotechnology, you will see in this pie chart that the dominant activity is in academic. There is a lot of research going on in traditional biosciences departments as well as several engineering departments now, followed by human health. I'm going to today talk about one application in the area of human health, and that deals with our effort of producing therapeutic proteins using a microorganism, Pichia castori. Pichia is considered as an emerging star for making a host of therapeutics. Now, if you look at the global therapeutic protein market,